Hi, welcome all to the today's session on automotive product design methods for acoustics, part one. So I have divided today's topic onto two parts because I don't want to rush on to complete the session within an hour. So I will probably take around, say, 45 minutes for the part one, and for part two, we'll have another 90 minutes of session. So let us understand what is the importance of acoustics, or how does an sound dampening application is so important in today's automobile. If you see for the futuristic vehicles, especially for electric vehicles or for the connected vehicles, or there's a lot of technological upgradations being happening onto the vehicle side in terms of the fuel economy, in terms of lightweighting, or in terms of the crash resistance or crash worthiness. And parallelly, there should be also an importance given for the cabin, or I can say to the large extent of a consumer delight, or a passenger or a driver. When he drives a vehicle, he should have a pleasant driving rather than taking the pain of driving and trying to reach his destinations. So that's where the acoustics topic is being taken to its surface and to its utmost importance. And there is a specified or in very devised area of its applications, especially onto the various platforms of an vehicle. So we will have a look around on, and we'll just have a very brief talk onto this topic. And then subsequently we have our programs, or a tailor-made program specifically for the bachelor's engineers or the postgraduate engineers who want to pursue their career onto the acoustics topic. So let us begin the today's slide, and what we see here is something. Let us park for a moment. This is something which talks about the generic life cycle, or the methodology which is being involved in developing an acoustics product. So it all begins with a basic understanding of the fundamental engineering, including the CAD and the FEA requirements, and it goes through a product knowledge or a domain knowledge, and subsequently you will have to gel it with some of the different applications as per the requirements for the sound dampening. So for the today's content, we'll have briefly, we'll talk about five major topics. So first thing is about me, myself. We'll talk just about 5 minutes on that. Then we will have a talk on the skill set pyramid and the product life cycle, about how does an product being evolved in an automobile. And then we'll touch down to the acoustics materials, sounds, noise sources, and the applications. Then to the noise impacts, and finally to the design solutions and noise validations. So this is some of a very structured way to how I want to start from the beginning of a concept design. Then it goes to the development. Then finally it goes to the vehicle validation, where it has to prove that the sound or the sound dampening is being used effectively. So first come first. So myself, I am Satish. I am currently pursuing my master's degree from BITS Pilani in automotive engineering, and I did my graduation from BITS. And I have my basic diploma in plastic mold making from CIPET, Chennai, way back in 1999. So it is exactly been 2 decades or 20 years that I have been into this industry of automotive body engineering design for interiors and exteriors components. And my specialization starts with the tooling, manufacturing of the injection tools and dies, sheet metal components. And I had an extensive experience onto the product development of a dashboard, door panels, and as well as the bumper systems with various organizations in India. And if I look here, this is a career graph onto which I started my career after completion of my diploma from CIPET in plastic mold making in the year 2000, where I worked for a couple of small scale organizations there into the manufacturing of injection tools and dies. And then I switched over to TCS, where I had a brief stint on to designing of gas turbine and steam turbine products. That was not all that related to the automotive. Then after a couple of years, I felt stagnated and bored, I can say, to a large extent. And then I had to come back to my technical area of expertise. Thus, I got an opportunity to work with some of the leading tier 1 organizations in India, such as Sumi Motherson, IAC, Raymond Fasteners, and Tata Auto Components. So these are some of the companies onto which I was associated in developing most of the interior components for the local OEMs, such as Tata Motors, Mahindra, and GM India. And my last association was with Plastic Omnium for about 7 years. I was handling a team on a position called engineering project manager, and I was delivering exterior car lines, bumper systems for Mahindra and GMI. And then I formed this Living Solutions about 6 months back for myself and with my friend, and we are more focusing on to the design execution of projects related to the EV platform. And we also provide domain-centric training program for bachelors and for postgraduate mechanical engineers. And finally, we provide an internship project for those who are passed out from colleges and they are looking out for a suitable job. So we have a very extensive hands-on experienced sort of a tailor-made internship projects who are willing to take up their career onto the product design functions. So let us spend some time to understand about what is the skill, knowledge, competency. So it is not anything to do with the acoustics, but I just want to give some prior prerequisites for those who are watching my session for the first time. Usually I conduct webinars and seminars on colleges. So I just thought of having a recorded session for most of the viewers where you can try to understand. So this is basically for those who have not been a part of my earlier sessions. So if you look at this pyramid, you can see that at the top of the pyramid, it starts with a low count from 10%, 20, 30, and subsequently goes to 90. So what you find on top of the pyramid is that, so this pyramid talks about the skill of how much you need to develop, what is the process and what is the methodology of how to go about it. So if you look at the 10% and 20%, it's all about reading and hearing. There's nothing onto the practical mode, or you do never do it anything onto the practical side to really enrich the qualities of what you have heard and read. So that's where you need to take an initiative or to have a self commitment so that you can try to do for yourself through lab sessions. So that is the initial step by which you start pitching in, and eventually when you come to a level of 50% as per this pyramid scale, that the 50% is summarizes that you take a note of the read the lectures and observations with practical sessions. And if I correlate the same situation onto our domain centric training program, this is what we are trying to teach most of the graduate engineering students, that you begin with this reading and lectures on your day-to-day classes onto your bachelor's programs, but then eventually you will have to step out from the theoretical class and you need to focus on how to start developing components. And that's where we come into the picture, where we try to facilitate by giving you a hands-on experience about how and where you need to start developing and what is the methodological or what is the principles behind developing a component, whereby you get a good upskilled and credential for yourself, that you gain knowledge through the practical and lab assessments. So that is something which has to be nurtured. And further, from 50 to 70 and 80, it all starts building up. You are building up your confidence, you are building up your competency, you are building your experience. So that's what's all been written on to this slide. So you have to decide yourself from where you will have to start and from where you will have to go. So your journey is having from this pinnacle of the pyramid, and you have to drive all the way down. At least try to have and vision that you meet up to 70%, if not 80 or 90. Of course, if you have a possibility to have a plant visit or an industrial visit, or that is a very ultimate experience what one could have. So to correlate of what you have learned, what you have read, what you have did, that is a good platform. So this is what which I want to explain to you. I want to give you a heads up that most of you might be being held up with this KDX, Coursera, and Udemy and all. So it is all about the reading part of it, and it is not much to do with an student's profession. But if it is all good for those who are working professionals and who wants to upgrade their skills for their personal interest. So this is all about the skill knowledge pyramid, and let's walk on to this different levels of the knowledge enhancement. So what you see here is the level 1, level 2, and level 3. So I presume that most of you who have completed your 4 years of bachelor's degree would probably be on the level 1, that is only having a tool knowledge. Tool knowledge means it is about the software tool knowledge, might be a Creo, SolidWorks, or CATIA, that is to the CAD, or ANSYS, or Abacus, or any FES solver. So that is all something which the industry tends to address you only as a draftsman. So there's nothing much you can do beyond that. But then if you have to elevate yourself, you will have to focus on one specific application or a product. That is what you have to gain the product knowledge. When I talk about a product knowledge, it can be for any system or subsystem or component. It can be for interiors like dashboard, cockpit, floor console, door panels, or it could be for an exterior components like your tailgate, spoilers, rocker panels, bumper systems, ski racks, or it could be also for your BIW components like your front sheet metal zones, your roof panel, floor panels, and your long members. So those are the areas where you can try to focus. And when you have decided on which specific platform and which area you want to focus, that is what you have to nurture yourself into the product knowledge. And the level 3 is something which you try to enhance yourself once you first define a product, then you can think about enhancing it. For example, if I take a bumper system, so first of all you need to know how bumpers are being designed, right from the concept till the vehicle fitment. So once it is known to you, then you can think about doing some lightweighting, or you can try to do some integrations, or you can try to bring in more modular designs integrating with ADAS, cameras, sensors, lidars. So if you have to think about the level 3, the level 2 knowledge upgradation is quite important. This is what we emphasize, and this is where we try to provide you the domain-centric training programs on 7 different programs related to sheet metal, plastics, composites. So if you have to address your need for upskilling the product knowledge, then you'll have to commit yourself in acquiring that, so that it gives you a better and career mileage. Okay. So let us begin with our level 1 of design thinking process. So I presume that most of you might have completed your CAD program, might be at your home or from any CAD institute. That starts with your sketcher, where you constrain the geometry, then you go to the part modeling, and then you do the drafting mode. On the drafting, you try to put on the different views in this orthographic view or the isometric views. Then you try to place the dimensions, then you try to place some references, and then you try to pull the components together to make it as a product file, and then later on you get onto the FEA part of it to understand about the physical behavior of the phenomena if it is being applied under the different loads and boundary conditions. So I'm quite sure that this is the area where you might have been taught onto your colleges, most of the engineering as part of your academics, but your life doesn't stop here, and your job search doesn't start from here. So there is something which you will have to learn a bit more, you will have to stretch a bit more, that is up to level 2. Then you can say yourself as a confident CAD engineer or a product engineer, because you have addressed the thoughts of your employer about how to start defining a product design. So before we get on to the level 2, I just have to talk something on this specific graph. which talks about the time and knowledge, or the product knowledge that you acquired on a specific project. So if you see here this y-axis, it talks about the product knowledge that you have graded yourself, and on the x scale it talks about the timeline onto which the design takes place. So you can see here that there are light blue vertical lines. So these are the different phases of and design methodology. So it starts at the concept design, then it goes to an mid design review, then to a large scale design review, then finally you execute the design for tool manufacturing. So that's why I have been split into 4 different halves. So what do you see here? This particular magenta curve, it talks about the design freedom, that at the beginning of the concept stage, you have got much more of liberty to do n number of design iterations or fine tuning so as to meet your functional requirements or your customer requirements. But as you go down, you can see that as you pass through the time, your iterations requirements or your possibility to make any design changes is becoming a bottleneck. So for addressing this concern, you will have to look at this particular curve, which talks about the product knowledge, which begins with a very minimal level of product knowledge which you are bound to know for yourself. So you cannot try to start from zero so as to catch up the time for the design release. So as an employer, they are expecting you to at least have a minimum amount of product knowledge so that you will be able to deliver within the time frame for the design release. So this is where we try to help you in bridging up the technical gap and to also elevate a bit more from your level one thought process of design executions. So the bottom side, it is a very generic flow of the activities which starts with your styling concept phase. It goes to the design CAD, then you will have to validate the CAD, whatever you have done through the simulation, where it tries to deliver at least 80% of the confidence level. Then it goes to as prototyping. It's not very compulsory that you will have to do the prototyping, but whenever you feel there's a criticalness in terms of manufacturing or in terms of fitment, or if you're not sure about its functional responses, then you may or you might develop a prototype, or you can also do it on a digital mockup onto a CATIA. And then further it goes to the manufacturing, and the manufacturing means it is for the manufacturing of an injection tool for plastic component or for a composite SMC or BMC, or it would be also for stamping tools. And then this chain goes ahead for next 1.5 years until you start manufacturing or start producing the vehicles for sales. So this is a generic flow chart which talks about the product knowledge requirements. So now let us have a quick look up on like what is or how does a product design evolution begins for an acoustics. So slowly we are getting into the arena of the acoustics, and we start thinking from the design methods. So the product design methods is a very important tool, or that's a very important platform one needs to understand about how to address a customer requirements. Okay, so that is something which you have to be learned and experienced, and which cannot be just taught over this seminar of 45 minutes. It doesn't happen like that. So you'll have to spend a good amount of time to really understand about what it takes to define a product design. And if you look at the acoustics material selection that you have got PU foam, the rock wool, there are some different types of acoustics material which comes into the picture, and it's not necessary that you develop these acoustics materials by yourself or by the organization where you work. Mostly this should be given to a tier 2 or a third party supplier who does and very intensive research and study to understand about its application side, and he tries to develop it and deliver to you to do for testing or do for any validation before it goes to the OEM. So this is one part of it. So developing an acoustics material. And when you come back to this product design of your substrate, so this is an injection tool where you have the core and cavity, and this is the profile which you get as a finished part once the injection molding process is completed. So you can see here that these are the finished components that are being manufactured by using the injection molding machine, which ranges from 50 tons to 4,000 ton range for right from manufacturing of a PET bottle caps till manufacturing of the bumpers and dashboards. So here, so by here, what is happening is that you have completed the manufacturing of the that particular product or the substrate, and parallelly you are also going to combine with this acoustics material. Put together, you will start defining it onto a vehicle. So and then you do an acoustics measurement. So for an acoustics measurement, you have got various tools that we will have on the following slides, so by which we try to understand about the different noise sources from where the noise source coming in, and then you try to develop a thought process about how to reduce the sound transmission loss, or when you talk about the sound pressure level or the sound intensity level. So these are the different terminologies being used onto this acoustics platform, and it has got its own very unique process of developing. Okay, that's why it's called as an NVH and durability. So that goes and hand in hand for vehicle development. So to just cut short, this is an life cycle about how an acoustics product is being developed, and we will have a detailed session on this once you enroll to our program related to this acoustics, where you will be taught right from the beginning of developing of a plastic component till the vehicle fitment of the acoustics product. So that gives you a good blend about the manufacturing, fitment, and all lot many things. So if you're really interested and curious to know about acoustics topic, then I would encourage you to enroll for our certificate program onto this particular platforms. So let us just begin with a basic thought process onto this acoustics basics. So probably this would be our last slide for us for the part one. So in physics, this sound is an vibration that propagates an acoustics wave through a transmission medium such as gas, liquid, or solid. It is all known to most of you because this is a part of our high school. That in physics you would have learned that a sound is a vibration. So here you can see, you can just correlate the situation that it propagates an acoustics wave. So it starts off and wave through a medium. So that medium can be an solid, air, or gas. So the speed of sound is higher in solids when compared to gas or liquid. So sound is a mechanical wave motion that carries energy from one point to another through a medium. So that is what is called as a sound. So now you will have to just correlate about the different sources of sound that can come into the picture. For example, that could be a sound coming from the engine room, or that could be a sound coming from the road and tire. That could be some sound coming from the structure, that is called as the structure borne noises. And that's how you differentiate between structure borne noises and then airborne noises. So structure means the mechanical sounds which could come or accelerate once the vehicle is in motion, and the air noises are the ones which are being as an effect of the specific mechanical systems. So here you can see that on the bottom side of it, this is a scale which talks about the human auditory field, that human can have and listening capability from 20 hertz to 20 kilohertz or 20,000 hertz. So that is the frequency range of human beings. So based on these factors, it is being decided about. First, you need to understand about from where the sound comes. Second one, you need to understand about how to dampen the sound, and also by considering the cost and quality factor. So just stay tuned for our part two. So we will park our discussion for the part one till this slide, and we will continue with the part two. So till then, thank you.